This is a gyroscope. Doesn't look like one, but it is. And it is a bicycle wheel, full-size bicycle mountain bike wheel. And it's mounted on this stand, bicycle stand. The stand is mounted on another plate, which is mounted on a Lazy Susan circular bearing, which is attached to this. And that is attached to this long piece of wood, which has two little legs, chopstick legs. So you see that the whole thing is going to balance. The gyroscope is going to balance this self-balancing bicycle wheel on two chopstick legs. And I made some other videos of me building this and doing this, and they were quite long and boring. And the problem with this bicycle wheel is it's very difficult to balance to run at high speed. So I actually put some magnets in here with zip ties to balance it as well as I could. But I can only get it up to about 800 RPM, and then it's just it's so out of balance that it won't balance itself. It won't balance on two legs like this. So I thought I would go the other way and see how low I could, low RPM I could balance this. And I'm doing this with an active mechanism here that there's a servo here, and it swings a counterweight back and forth. And it's got two sensors on it. It's got a MPU 6050 sensor to tell me the angle of this board. And then inside of this circular bearing, which you cannot see in there, there's a, maybe you could see it in here. No, can't see it. There's a potentiometer. So that tells me what angle. And you have to have two sensors. You can't just use a single sensor. It won't work. And between the two sensors, I can tell where this is positioned in angle, total angle, and the rotation angle of the circular bearing. And with Arduino Uno, I can calculate, well, I don't actually do any calculation really. I just, if it's leaning this way, I swing the weight that way. And if it's this way, I swing the weight back this way. It's a pretty simple little program. It's kind of a bang bang on and off program. Okay, so that's the basic mechanism, and here is my power supply to turn this motor, which has a race car or RC car wheel on it, and that turns my big one, the big wheel. And the reason I'm using a bicycle wheel is because it is the perfect gyroscope, because it has all the weight at the outside of the wheel. So now I will turn it on and turn it on to about 200 RPM. I've actually got it to balance a little under 200 RPM, but I'll do it about 200 RPM, and we'll watch this thing balance. Okay, I've got it turned up just a little bit, and the RC wheel is spinning my tire at around 200 RPM. So we'll see if this thing balances now. Okay, it swings the counterweight back and forth, which causes the inertia of the gyroscope to torque the whole mechanism back one direction and the other. And I'll try to get a view of it. So it is balancing on two legs, two chopstick legs. And it will run pretty well indefinitely, even at the slow RPM. Occasionally it will lose its balance because of something. I don't know what it is. Probably the sensor misread, so kept it on one side a little bit too long. But it can run 15-20 minutes before it might fall over. And I think if it was built more accurately, it would be less inclined to ever lose its balance. You can see here that one side of the wheel stand is shorter than the other, so it's at an angle. So it was actually very difficult to get this thing to find the center of gravity to place over the circular bearing accurately. So it's actually a little bit off, and that's why it's actually swinging clockwise, a little bit more clockwise than it is counterclockwise. I don't know how useful it is. There, it lost its balance. Now, if I increase the RPM, it would be less likely for that to happen. I also found that swinging the weight at a slower rate means it doesn't jerk the mechanism so much, so causes less problems with the sensor reading accurately. When you run at faster RPM, it doesn't need to move counterclockwise or clockwise quite as much. Uh-oh, now it's going to lose it again. But I think I can adjust it out in the Arduino, so it won't lose its balance. Set it up so that it stays a little bit more on one side than the other. Now what I'm finding is when it's spinning very fast, it precesses. The gyroscope will precess, but the radius of the precession is very, very small, and so it's more inclined to stay in balance. When you're running at very low RPM, the precession diameter is huge. So because of that, you have to go across the balance point and start a precession cycle, and then immediately make it go the other direction and start a new precession cycle on the other side of the balance point. And you're breaking the precession cycles and making them very small. If you allowed it to stay on one side for a complete precession cycle, it would have to, the diameter would have to allow this thing to lean so far out that it's not going to have enough torque to get it back to balance state. So the lower RPM leads to a wider precession cycle, and you need to break that cycle or it's going to lose its balance. When it's running very, very fast, if I could run this wheel at 2,000 RPM, it wouldn't even need this mechanism, the counterweight mechanism. It wouldn't need it at all. All it would do is it would keep itself in balance, because the precession radius is so small that it'll constantly maintain its own balance. But with low RPM, the precession diameter is so huge that you need to break that cycle or it will lose its balance. Yeah, it's keeping its balance pretty good now. I'll show you once more. I don't really know what this could be used for. I just thought it was interesting to see how low you could balance, or how low on RPM you could balance this thing. Now, I used ChatGPT to try to give me some formulas to calculate what is the minimum RPM that you need to balance a bicycle wheel. And it calculated, the calculations it gave me were down to around 120 RPM. And I'm not too far off of that. I can get it down under 200 RPM, just barely. I think I had it balancing at 180. And those formulas are for an ideal world with a perfectly balanced mechanism, without wind resistance and all these other factors that you need to consider. So it's actually fairly accurate in the calculations that it gave me. You can see that it's actually balancing more to the right, more to the clockwise direction. And I think that is mostly because this machine itself is so out of balance in itself that it's compensating for it. So if I had a good stand, a perfect stand where both sides are equal length, it would actually balance more in the middle. But you could program this. You could actually program this back to pull the balance back in line with the platform that's holding the legs. I guess my next step is to see if a PID program would actually make this a little smoother. Right now it's a bang bang. So if it comes this direction and reaches a few degrees beyond the set point of 0 degrees, it will immediately go back to the other direction, and then once it goes beyond a certain level of degrees from that point, it will immediately come back to this direction. So it's just bang bang going back and forth. This is the same concept that's used in the Gyro X car from the 1960s. It used a single rotor, and it didn't use a counterweight. it used an active mechanism to control the turning of this the gyroscope. Now, I've built other models that have done exactly that and not used a counterweight. The counterweight is just kind of an easy way to set this up. I could put a pulley on here, a motor there, and the motor with the motor driver controlled by the Arduino, it would replace this swinging counterweight, and it would automatically compensate, and it would do a much better job than the swinging counterweight. And I've done that before with other models, and I may do that with this one. I don't know. My wife keeps telling me to tear this thing all down and get my work table back, but it's so much fun to just watch it work and to piddle with it a bit, but I hate to tear it apart. So I think I might do another video at least where I just change the program. That's all I have to change, and put in a PID algorithm so that the counterweight won't have to swing so hard, so far, and it'll swing just enough to get the balance restored. Right now, it automatically swings the full distance, 80 degrees. Yeah, it's running good now. This is about the ideal RPM, I guess. I'll see what this RPM is. I hate to stop now, but it'll probably run 15-20 minutes, and then maybe it might run indefinitely. I don't know. I've had to shut it off so many times because it was running so long that I just got tired, and so I didn't go until it actually lost its balance. And I think I can set it up to run indefinitely if I play with the program a little bit more. It always seems to catch its balance when it's going clockwise, turning clockwise. But if it ever goes too far counterclockwise, that's the side that it'll lose its balance pretty easily. And that can happen because maybe I got a bad reading on the accelerometer, the MPU 5060 sensor. So because that is very subject, this sensor is very subject to vibration, and this thing's got a lot of vibration going through the whole platform, the frame. The potentiometer is not so subject to vibration, and it's quite accurate. It doesn't, I can watch it on the serial monitor on the computer, and it doesn't, it stays pretty steady. But that sensor, it jumps around a bit. So if I had a better sensor to determine the angle of the platform, it would even be more accurate, and would never, I don't think it would ever lose its balance. Anyway, there it is. What I'll do is I'll stop it now, and I'll just rest it on its platform here and try not to get my wife's curtains mixed up in the wheel. Okay, there. And now I'll take a quick reading of the RPM. and it's 347. So RPM of about 350 seems to work quite well. A little below that and it will tend to lose its balance. Let it run again. And actually, if it's too high, it looks like it will lose its balance because perhaps because I'm only using a few degrees left or right of the center, and if I widen that at higher RPM, it would probably run better. So the few degrees that I'm using right now seems to work well with the wheel spinning at 350 RPM. But I have gotten it to balance down below 200 RPM, which is quite amazing. All right.